last practice final that starts with chapter 8. Today this video will cover up through to number 29, and you should have by email an answer key. So if you have the video and the answer key and your own paper all in the same area, that's probably the best way to watch this video. If you need more real in-depth detail on any of this stuff, I think there's videos for all of this information. I think this is about where the quarantine kicked in. Was right around chapter 8 for us. So I think there are a lot of videos and materials and things out there even beyond this. Number one, we're just looking to cancel. So 5 cancels 20, that leaves a 4 on the bottom. And then the x's cancel, you'll get an x on the top, because the top had one more x than the bottom did. There's also a thing called a restriction. The idea of the restrictions are the bottom's not allowed to equal 0. So the restriction answer is that x is not allowed to equal 0. Because if you put in 0 on the bottom, it would make the bottom 0. If you did 20 times 0 squared, the bottom would be 0, and that is just not a thing that's ever allowed. For 2, we want to factor and then cancel. So the top is a thing called a difference of squares. Difference of squares have even powers that we cut in half to get x's. They have a minus that causes us to get 2 different signs. And it has a number we can square root, 4 we can turn into a pair of 2's. The bottom, we're going to factor in the normal way, x and x. The plus with the 10 tells us these are the same as the 7's sign, so both minuses. And when the signs are the same, we add to make the 7. 2 and 5 can do that, while we have to multiply to make 10. We factor so that we can cancel, and one of the answers would be this on top of that. The restriction answer, we want to say x is not allowed to be 2 because it would mess this up by making this 0. And x is not allowed to equal 5 because 5 would mess that up by making that 0. 3, we're back to just canceling. 6 can cancel 2 to leave a 3 on the top. For the x's, there's one more x on the top, so leave an x with the 3. The y's completely cancel perfectly, so the answer is just 3x. For us to be able to cancel 4, we have to factor first. Anytime you see adding or subtracting, you can't cancel unless you can first factor. So the top of 4 is another difference of squares, an even power that cuts in half, a minus sign that becomes different signs, a 16 that becomes 4's. And then remember, the second bottom invisibly is in parentheses, so we can make those visible if you want. X plus 4 is a perfect match for 4 plus x. Those are considered to be the same thing, so we can cancel them. If they were subtracting out of order, we'd have to leave a negative sign to balance that out, but adding, we can switch the order anytime we want to. This x can eliminate one of these 3 x's to get that down to 2, and this answer would be a 5x squared, and then the x minus 4 in parentheses. 5 is almost the same as 3, you just flip the second fraction. Flip the second fraction and that lets you cancel. So what we have going on there, once we flip, the 3 could cancel the 18 to leave a 6 on the bottom. The 4 could cancel with the 12, leaving a 3 on the top. But that 3 on the top could cancel the 6 on the bottom we just talked about to leave a 2 on the bottom. For the x's, there's one more x on the top, so do an x there. For the y's, there's one more y on the top, so leave a y up there. 6 will have to factor to be able to cancel. Again, there's a difference of squares on this top. That's an x plus 2, x minus 2. The second fraction has to flip. And we're going to factor that bottom. The plus with the 2 means these are the same as the minus sign with the 3. 2 and 1 will cooperate on that. If you like to make your invisible parentheses visible, feel free. And then we look for matches. X plus 2's are a match. X minus 1's are a match. And even though these are a match, they don't cancel because they're both on the top. We can only cancel tops with bottoms. So the answer is x minus 2 squared. 7, we want to just look at the bottoms at first to pick a common denominator. This first bottom would factor to be xx, different signs because of the minus on the 10. Minus takes the bigger number, which is 5, compared to 2. This is invisibly in parentheses. Then what we want to do is make these two things have a common denominator. This, in terms of the common denominator, is considered basically the same as that. But even though they're backwards, they're still considered about to be the same. What we lack over here on this fraction is an x plus 2. So for our common denominator, what we're after is picking one of these, either one, it doesn't matter, but we also need an x plus 2. I'm going to pick to do it this way, which means I prefer for that one to get reversed. Subtracting, to reverse it, I changed the sign on the bottom. I'll need to change the sign on the top where there had previously been a 9. This had an 8 all the way. For this to be a perfect exact match for the bottom, it also needs an x plus 2. And if we're going to multiply x plus 2 in on the bottom, we'll have to multiply x plus 2 in on the top. And that just accomplished our mission of common denominators, and we changed the tops. 8 is just a matter of adding across to get 16 and leaving the bottom alone, 4x, but then recognizing you can cancel 16 with 4 to leave a 4 on the top of the x. 9, we need to make a common denominator, and you might want to make these invisible parentheses visible. When we go to pick a common denominator, we need x plus 1 involved. We also need x plus 2 involved. Anything that we see, we pick it the most times that we see it. Anything that's there has to be in the common denominator. So if we want this on the bottom to also incorporate this x plus 2, if that's going to appear on the bottom, that has to appear on the top and be distributed out to get 5x plus 10. For this to have the bottom we want, we need x plus 1 on the bottom. So we also need it on the top, and we'll need to distribute that out to get 6x plus 6. And then combine like terms. The tops here, we get 11x plus 16. For 10, the 6 is like it's over 1. To add these, we need a common denominator, so this needs an x. And if the bottom needs an x, the top needs an x. If we try to add 6x plus 7, you really can't, because they're unlike. Just leave the x on the bottom, and that's what our answer would be. 11 is called complex rational expression. That means there's fractions inside of other fractions. What we always have done here is pick an LCM. Looking at the bottoms, I see x's and y's, so I need an x and I need a y. The job of that circled LCM is going to be to cancel the bottoms and potentially to multiply the tops. So here, the x's would cancel, the leftover y multiplies the tops. For this part of the world, the y's would cancel with a leftover x to multiply the top. For this part of the world, the x's would cancel, a leftover y multiplies the top. And for this, the y's cancel with a leftover x also multiplies the top. If you did that, that's pretty good, but that can simplify. We always look to factor. This has a top a GCF of 3. The bottom has a GCF of 8. When we factor, we have a match there that we can cancel. Best answer is 3/8. For 12, we're just looking to divide the 2 into each thing. When we divide, we remember to subtract powers. So the 4 dividing 2 is a 2. Subtracting the powers is x squared. Then there's a minus. 6 divides 2 is 3, and the variables are a perfect match. Ignore them. Then there's a minus. If you had 12x, try to divide 2x squared. 12 dividing 2 is 6, but we still need this last piece to be a fraction because there were more x's on the bottom. An extra x on the bottom compared to the top leaves that as the last piece of 12's answer on the bottom. 13, we're long dividing, so the x minus 2 goes out of the box, and we'd start off just dividing the beginners. This dividing this would be x. Whatever you make on the top has to multiply everything. So x squared minus 2x. It's like a distribute problem. Now we'll subtract. The beginners will vanish because they're a match, and when you subtract matches, they vanish. Negative 6 is subtracting negative 2. So subtracting a negative, it's really an add. -6 adding 2 is a -4x, drop to +8, and then do another cycle. Divide the things at the beginning. When this divides this, the x's vanish, and it would be -4. Anything you make up here multiplies everything. -4x plus 8 when we multiply. And then we look to subtract, and we kill off both of those terms. And there is no remainder. Sometimes there is a remainder. This one there is not. 14, ratios or fractions. Just put 40 over 12 and then reduce it. 15, anytime you have two fractions, look to cross multiply. The 7 multiplies the x to make 7x. That's equal to 210 from 21 times 10. And then just do opposites. Variables multiplying 7, so we'll divide by 7. 16 is another cross multiply problem. 25 has to distribute the x plus 1, and that's equal to 75. And then you just go about doing your opposites. 17 is different because there's not just two fractions, there's three things. So we're back to the idea like the complex where I had a thing circled a minute ago. Look at the bottoms, pick an LCM, which would be an x. The circled LCM's job is to cancel all the bottoms and possibly multiply some tops. So x cancels x to leave 1. X cancels x to leave 3. X needs to multiply 24 to get 24x. And now that's an easier problem to do. 1 plus 3 is 4. And then we have to divide by 24. 4 over 24 can reduce. 18 is like 17. Pick an LCM. 5, 2, 10, all go into 10. And there's also an x onto bottoms. So 10 can cancel 5 to leave 2. To multiply the other 2 on top, and I created a 4. 10 cancels 2 to leave a 5, but there's also an x there to multiply the top and get 5x. This completely cancels this and just gets a 3. And then we'll do some opposites. We see add 4, so we subtract 4, that's a -1. And then divide by 5, you get a fraction, -1/5. 19 is just some memory. 19 is the origin, vertical axis is the y-axis, 21 is the x-axis, 22 you could write anything out of change in y over change in x, y2 minus y1 over x2 minus x1. You could say steepness, you could say rise over run, you could have the subtracting problems both go backwards, any of that's fine. 23 for an x-intercept, you could either tell me that's where we cross an x-axis, or you could tell me that's where y is 0. Just pick an answer. If I asked you about a y-intercept, you would just have to switch that to be more talking about the other opposite x or y answer. 24 is left 2 because the first number is always left or right, just like the number line negative would go left. And then up 3 because the second number goes up or down, up being positive like a thermometer would run. 25 intercepts are coordinate pairs that look like this, that have a 0 involved. So if we're thinking about x being 0, just cover up x with your hand, do an opposite to divide -5, and you could come up with -4. If we're thinking about a number like this, that's where the y is 0, cover that with your hand, and then divide by 2's, the x would be 10. I'm going to use that same trick to graph 26. For 26, if x is 0, the y we could figure out is 4. That would be a point up 4. If y is 0, cover that with your hand. X is 5, go right 5, and play a little bit of connect the dots. 27, if it's in slope-intercept form, that means that the y is 11, it's y equals. We can just graph straight from the equation. The +1 part means to go up 1. The 2/3, we can think about the slope formula. The top is always sending you up or down if it had been negative. And the bottom always sends you right no matter what. So the 2/3 from here just goes up 2 and right 3 for you to play connect the dots and make a line on that. 28x is this one. So an x of -1 would go left 1, and then it just stays left 1 going straight up and down. 29 doing slope, we're back to working that formula. The y's have to subtract to make the top. Okay, this is an x, this is a y. This is an x, this is a y. So if I want to subtract the y's, I could either go 3 minus 5. I feel like I'd rather do 5 minus 3 because that's positive. So 5 minus 3. And then subtract the x's in the same order on the bottom. 5 minus 3 gets me stuck with 3 minus 2. 5 minus 3 is 2. 3 minus 2 is 1. 2 over 1 is better written as just simply 2, and that's the slope. Next video, we'll pick up at 30 and go to the end of that paper.